Hey everyone, hope you're all doing well. I'm using a different platform to show my iPad screen and my laptop, so it might be a little different. I think it'll be promising and it'll look good. But yeah, that's basically it. And for today's video, I'll be talking about primary trigonometric ratios and why and when do we use them and how to use them. Yeah, that's basically it. To start off, I'm gonna say a joke that's regarding trig. And so the joke is, what did the right angle say? Wait, actually, never mind. The joke is too obtuse. Guys, that was the best joke ever. Okay, relax. And then that's the joke. Um, and we'll just move on now. So you're going to be learning primary trigonometric ratios and how and when to use them. So you would use primary trigonometric ratios to solve for a triangle side or solve for a triangle angle. And these primary trigonometric ratios only work for right angle triangles, and you have to be given a certain set of information in order to use it, either two sides or an angle and a side to solve for something. And it'll make more sense once I get into it. So the acronym we use to help us remember the primary trigonometric ratios is SOHCAHTOA. SOHCAHTOA. And so I segregated them off to show what SO, Ka, and Toa mean and what they represent. And then that's basically it. So starting off with So. So means sine. So this S means sine. And the OH means opposite and hypotenuse, right? And the general formula would be like sine theta. And if you don't know what theta is just an what am I saying? Unknown angle, right? And theta is an unknown angle, and the OH represents the numerator of the equation, and this represents the denominator. So now, if we look at the actual equation, it's just sine theta equals opposite over hypotenuse, right? And that's basically it for So. If we go down, I wrote a little bit more and I put it into perspective of a right angle triangle. So if you don't know how to label a triangle, right, which one's the hypotenuse, opposite, and adjacent, right, here it is. And I'll teach a little bit about labeling also very soon, and just basically how to label a triangle. And that's what these are. Sine theta equals opposite over hypotenuse. These are side lengths. And what we have to do is, if we're given both the side lengths, so if we're given both the side lengths, we have to solve for theta. If we're given one side length and an angle, then we have to solve for the other side. So say, for example, we are given this, given this and this, right? We have to try to figure out what h is, which is the hypotenuse, right? Or say we're given this and this, we have to figure out what the angle is, theta. And that's basically it. Here's again the diagram. The theta again is this unknown angle right here. And that's pretty much it for sine. Let me see if I have anything else down here. No, that's it. And then for Ka, this represents cos, right? And cos is going to be written as the formula cos theta equals adjacent over hypotenuse. And if we use the acronym Ka, again, the second letter is your numerator, and your third letter is your denominator. I'm just going to put num and den. And then what I have highlighted is C because C tells you that it's cos. And so far we just covered sine and cos. Those are your two primary trigonometric ratios that you have seen so far. And your third one is TOA, otherwise known as tan. And for tan, you have to be given the opposite or the adjacent side lengths, or theta, obviously, in order to solve. And the formula is written as tan theta equals opposite over adjacent. Because TOA, again, remember, second letter is the numerator. The third letter is the denominator. Guys, I'm very lazy today writing num and then, but it's fine. As long as you understand it, it's fine. And then yeah, I just have the triangles here. So actually, it might make more sense if I highlight it. So for sine, you have to be given the opposite and the hypotenuse. For cosine, cos is just short, but oh no, sorry, my bad. What am I even talking about right now? Sorry, cosine is a completely no, cosine is is cos. What am I talking about? Yes, cosine is just the longer version of cos, right? Just as tan is the shorter version of tangent. My bad. Okay, we got that covered. So for cos, you have to be given the adjacent and the hypotenuse. And for tan, we have to be given the opposite and the adjacent. Yes. See, there's multiple combinations, and that's pretty much it for figuring out sine, cos, and tan and where to use them. And now if we go here to the next page, I won't do this one because I'll get to labeling now. So what we have to know about labeling, right? If you don't know how to label a triangle with primary trigonometric ratios, it's not that hard, right? You always when labeling a triangle, you have to make sure it's a right angle triangle, and then you have to make sure you're given enough information to work with. The only information that you need is theta. Where is theta? Because where theta is, right? And again, theta is this right here. Where theta is depends on what your sides will be. So if theta is where it is right now, opposite of theta is, maybe you can guess it, opposite of theta is the opposite side. Pretty self-explanatory now. Opposite side. And then we already know that the biggest side of the triangle is the hypotenuse. And the hypotenuse is directly opposite of where the right angle is. So here we have the hypotenuse. I hope that's how you spell it. This E is probably not there, but it's fine. And then obviously using process of elimination, the other side is the adjacent side, right? So this side will be the adjacent. Oh my, how do I spell it? Okay. Adjacent. And that's basically it on how to label. The other way you can figure out if it's adjacent is it's always adjacent to the angle theta also, right? Because here's angle theta and it's just right here. So that's basically how to label a triangle. Here's a more thorough and labeled diagram. But yeah, as you can see, theta is now down here. And again, anything opposite of theta, what's opposite of theta is the opposite side, which we have labeled here. And then we know the longest side is the hypotenuse, which is opposite of the right angle. So here we have the hypotenuse in blue. And the adjacent side is the last side, or it's adjacent to the opposite side. And it's right here. So now, I will go over some practice problems with you, and then you should be set for just knowing the basics of primary trigonometric ratios. So starting off with this question right here. I don't have anything written down, but what would be written down is solve for theta, right? So this would be solve for theta. So how do we solve for theta? We are given two side lengths. We don't know which side lengths. And we have to figure out how can we solve for theta given the information we have. So we are given two side lengths. We can use a primary trigonometric ratio to help us. What side lengths are we given? Well, we would know if we label the triangle. So if we label the triangle, what's opposite of theta is the opposite side. I'll just say that as op. And we know the longest side is the hypotenuse, my bad, hype for short. And then below is the adjacent, and I'll do ADJ for short. So now we have the three side lengths. Give me a second. We have the three side lengths, the opposite, hypotenuse, and the adjacent. Now, look at what we're given. We are given the adjacent side length and the opposite side length. So now, if we look back at the acronym, and wow, can I fit this? Yes. SOHCAHTOA. Let's see what we're given. Let's go to sine first. Are we given the opposite and a hypotenuse? We are given the opposite, but we are not given the hypotenuse. Now, this goes into further depth because you can actually use sine, even though we're not given the hypotenuse, because for a right angle triangle, what can we use to figure out the longest side of a triangle, or any side of a triangle that is right angle? We can use Pythagorean theorem. So if we really wanted to use Pythagorean theorem, we could figure out the hypotenuse and use sine. But what's the point of doing extra work when we can see what other options we have? So let's move to cosine, cos. Are we given the adjacent? Yes. Are we given the hypotenuse? No again. So we could use cos, but we're still not given the hypotenuse, but we could find it. But now let's go to tan. We're given the opposite, yeah. We're given the adjacent, so maybe we can use tan. So let's write it out. So tan theta, we're just going to copy the formula. Tan theta equals, now O is the numerator and A is the denominator. So we're going to say opposite. And you don't have to do all of this work. You can just say O and A, opposite and adjacent. So now what we do is tan theta equals, and we plug in those values, 4/3. And now how you solve this is not that hard. All you have to do is isolate for theta. And how you isolate for theta is by taking that tan away from it. You might be thinking, how do you take the tan out, or how do you even calculate that, right? When you're calculating for an angle, what you're always going to want to do is actually take the inverse. And by I mean by inverse is, you'll see on your calculator, every calculator is different, but it'll say tan to the power of -1 at the top. And then you plug in 4/3. So it'd be written as tan -1 4/3 equals theta. And then you just punch that into your calculator and you get what that angle is. Oh, I don't have my calculator. Give me a sec. Let me be right back, because I cannot do the raw math, because there's other mathematical things behind it that you just need to plug on your calculator for this. But I'll be back. Let me grab my calculator. Okay, guys, I am back with my calculator. So, if we look at this solution now, so if we plug it in, go on your calculator, it's probably in the shift. It's in the second gear. So you have to do shift, and you should see, when you click shift, click tan again, and then you should get tan -1, and then you just plug in the whole values, 4 divided by 3, and you are left with am I doing something wrong? Oh, my calculator's in radians, my bad. Oh my, I'm like, what answer am I getting? Okay, man, wow, that really threw me off. Okay, again, make sure your calculator's in the right mode. There's degree mode and radian mode. Radian mode you will use when you do grade 11 math, and Potentially grade 11 math, maybe even grade 12 math. For sure, probably grade 12 math, depending on what you take. But yeah. So now if it's on degree mode, then you do, again, tan inverse 4 divided by 3. And that will give you 53. Theta equals 53.1301, and then dot, 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 dot. It just goes forever. And remember, this is an angle, so we have to have a degree sign. But let's just round, right? I'll just round down, and it will be 50. I'll just round wholly 53 degrees. And then that's your answer. That means this angle right here is 53 degrees, around 53 degrees. And that's basically it. That's how you just solved an angle. So let's go to the next question. And let's see what we're given and what we can do. So let's first label it. It always helps to label it so then you can see what you can use. So we remember, anything opposite of theta is the opposite side. So this will be the opposite. Anything opposite of the right angle is the hypotenuse. And the last slide is just the last side is just the adjacent side. And again, it's adjacent to the angle theta. So now let's see what we are given and what we can apply to the SOHCAHTOA acronym. Let's see. Can we use sine? Are we given the opposite? Yeah. Are we given the hypotenuse? Yeah. So we can use sine. Let's see if we can use cos or tan. Can we use cos? Let's see. Are we given the adjacent? No. So we automatically can't use it. What about tan? Can we use, do we have the opposite? Yeah. But do we have the adjacent? No. So we can only use sine. And usually in most cases you just have to, you will use one primary trigonometric ratio. But for this one you could also use Pythagorean theorem, because if you do 7 squared minus 4 squared and then the root of that answer, you will get the adjacent side length, right? Because Pythagorean theorem will work on any side in a right angle triangle. But let's not do extra work and just stick to what we have. So we can use sine. So the formula is sine theta equals opposite, did I spell it? Yeah, opposite over hypotenuse. Oh my, hypotenuse. I hope that's right. And then now, what are the measurements? So the opposite side length is 4. The hypotenuse is 7. So sine theta equals 4 over 7. And again, the same concept applies. We're going to do the sine inverse of sine in order to isolate for theta. Again, on your calculator. So sine inverse theta. Oh my gosh, theta. Sine inverse 4 over 7, my bad, equals theta. Now let's plug that in on our calculator. We are going to get 34.84. So theta equals 34.8499, whatever. Now if we round, theta equals 35 degrees, for example. And then that's what your angle would be. Therefore, this angle right here is going to be 35 degrees, around 35 degrees. Now let's do this one. This last example, and it might be a little harder because it might involve a little bit more steps, but we will get through it. So we have to see what we are given. We are given an angle now. We are given 54 degrees and a side length. And we have this x value. So in this question, I want you to solve for x. You can try it right now, pause the video, but I'll just take it up if you don't know how. So we are given 54 degrees and 5 centimeters, and we have to solve for this x value. So again, labeling the triangle would be very helpful to see what primary trigonometric ratio you will need to use. So this, anything opposite of the opposite angle, opposite of the angle theta is the opposite side. Opposite. And then anything opposite of the right angle is the hypotenuse. So x is the hypotenuse. And then we're left with the adjacent, as it's adjacent to the angle theta, or the unknown, well, not unknown angle, because 54 degrees. We're given it. So yeah, that's it. So we labeled it. Now let's see what we have to solve for. We have to solve for x. So in order to solve it, we have to use a primary trigonometric function that has that has the hypotenuse and the adjacent in it. So let's see. SOHCAHTOA. Let's see. Can we use sine? Does sine have opposite? We don't have the opposite value, but we have to solve for hypotenuse. So we're not given enough information to use sine. What about cos? Oh, we're given the adjacent, and we have to solve for the hypotenuse, and we are given an angle. So maybe we can use cos. And we have to use cos, because if we use tan, again, we don't have the opposite side length, so we cannot possibly use tan. So we will use cos. So if we use cos, if the formula is cos theta equals adjacent over the hypotenuse, and let's sub in values now. So we are given the angle, and remember, this angle right here, whenever we say cos theta, that's an unknown angle, but in this case we are given that angle. So we're going to say cos 54 degrees equals the adjacent over the hypotenuse. So let's see, adjacent is 5, and we have to solve for the hypotenuse, so we just have to put it over x, and then that's basically it. So now, how do you isolate for x? Now, just like BEDMAS, we have to isolate x. So we have to multiply it on both sides. I'll do it in another step, but 54 equals 5 over x. And let's multiply it, the whole thing, by x. So then this x cancels out, and we are left with x cos 54 equals 5. Now, how do we isolate for x? We can actually take cos 55 and divide it by itself. 54, my bad. 54. We can take cos 54 and divide it by itself in order to isolate x. But what we do on the left, we have to do on the right. So we have to also divide this by cos 54. And now, since these two will cancel out, cos 54, x will equal, and now you just use your calculator again, and make sure you use brackets, because sometimes your calculator is not that smart. Okay, guys? And so it's going to be 5 divided by, and I would put brackets, cos 54, and close the brackets. And let's see what I get. I get 8.506. So 8.5065, whatever. And therefore, the hypotenuse length is going to be 8.5. I'll round till there. 8.5, and then remember, don't forget your units. 8.5 centimeters. So guys, that's basically it for today's lesson. It's not that bad. Primary trigonometric ratios are probably very simple. They're probably one of the simplest trig type of concept you will probably learn. And in higher grades, you're going to do way more advanced things than this. These are just the basics of trig. And yeah, that's practically it. And you might be wondering, why did I say that trigonometric joke in the beginning of the video? Because I can. And guys, that's the end of my video. Thank you for watching. Please leave a like, subscribe, comment, and share, and give me any feedback through the comments. And thank you everyone for watching, and I hope you have, wow, I can't speak English. I hope you have a fantastic day, night, evening, or whatever time it is for you. Bye everyone.